Hello students. Now this is the class for semiconductor electronics part 2. See, in the last class we have read about these band diagrams on the semiconductors. Now here straight away we will go for p-type semiconductors, n-type semiconductors, etc. Now if you go for a periodic table, then you have this in group 4, group 5, and there are group 3 elements. Now in case of group 4, there are the elements carbon, silicon, germanium, Sn, tin and lead. And the group 5, that is nitrogen, phosphorus, arsenic, antimony and bismuth. And the group 3, boron, aluminium, gallium, indium and titanium. So in modern periodic table, it is of course group 13, this is group 13, this is group 14 and group 15. Now, whatever it may be the case, the valence electrons, the number of valence electrons for any group 4 elements is 4. For carbon, the number of valence electrons is 4, silicon is 4, germanium is 4, tin is 4, lead is also 4. And the number of valence electrons in case of nitrogen, phosphorus, arsenic, etc. in group 5 elements is 5. And number of valence electrons in case of group 3 elements, boron, aluminium, gallium, indium is 3. Now, whenever there is an amalgamation between group 4 and the group 5 elements. Now suppose before I go to there, I must have to tell that silicon and germanium, these two elements can work as an intrinsic semiconductors, silicon and the germanium. Now if there is a doping from external agent by phosphorus P or by arsenic, then there are 5 electrons in phosphorus and arsenic, and there are 4 electrons in the silicon and the germanium. Now, to fill up the octet, we need 8 electrons. So here 4 electrons and here 5, so total 9 electrons, so 1 electron is extra. So by this 1 extra electrons, it will form basically an n-type semiconductor, in which the majority carrier is electron. Whereas when there is an amalgamation between the germanium and the gallium, suppose, then there are 4 electrons here, there are 3 electrons here. So 1 electron extra needed to fill up the octet. So naturally, there some from other places, the electron will come here to fill up. And from the places where the electrons will come, there a hole will create. So as a result, here a p-type semiconductor is formed. So p-type semiconductor is formed when there is amalgamation of group 3 and the group 4 elements. An n-type semiconductor is formed जब ये ग्रुप 4 और ग्रुप 5 एलिमेंट के साथ अगर कोई सेमीकंडक्टर तैयार हो जाता है, तो इसमें आपको एन टाइप सेमीकंडक्टर बनता है. और पी टाइप सेमीकंडक्टर बनता है ग्रुप 3 का कोई एलिमेंट है और ग्रुप 4 का कोई एलिमेंट है, उस दोनों को मिला के पी टाइप सेमीकंडक्टर बनता है. सो दिस इज अबाउट पी टाइप सेमीकंडक्टर्स एंड एन टाइप सेमीकंडक्टर्स. सो वेरी वेल वी अंडरस्टूड हियर दैट इन केस ऑफ पी टाइप सेमीकंडक्टर्स, the majority carriers is holes, and in case of n-type semiconductors, the majority carriers is electrons. Whereas the minority carrier is also there. So in case of p-type semiconductors, we have the majority carriers holes, minority carriers electrons. Electrons are minority and holes majority. So in case of n-type semiconductor, just reverse. Majority carriers are electrons and minority carriers are holes. And when these P and N junction, when these P-type semiconductors and N-type semiconductors, suppose there is a P-type semiconductors and one is N-type semiconductors. Now this P-type semiconductors and one type semiconductors, one side, you just make it fuse. इसको गला के अगर आप fuse कर देते हैं, एक साथ इसको लगा देते हैं, तो एक P-N junction तैयार रहता है. So a P-N junction has been formed. So this is called a P-N junction semiconductors. So in the next class, I shall talk about this forward bias and the reverse bias of these conditions of the P-N junction semiconductors and how the current is being produced and what is the value of the current in case of P-N and P-N junction semiconductors. So before that, I shall again thanks to all the students and enjoy the classes.